Welcome, hackers. Welcome to another 0xHackMeetup. Today we have Daniel Kmak with me, who's going to tell you all about building on other blockchains. So if you're interested in building on blockchains other than Ethereum, this is the talk for you. It looks like Throsten from CryptoManufaktur is not going to be joining us. So we're going to do just one session with Daniel. An update about 0xHack. We're planning on doing an offline meetup here in Warsaw. So if you're a member of the Warsaw or Polish blockchain community, you can reach out to us and we can try to organize something interesting for the blockchain community here in Poland. But today we're gonna go virtual and let's welcome Daniel. Hi, Daniel.
Hi, everyone.
Hey, Daniel. I'm gonna give you the stage, so guys, enjoy and good luck, Daniel.
Thank you.
Just one more thing. If the audience wants to ask any questions, feel free to drop them in the YouTube chat, and we'll be able to answer them during the Q&A session after the talk. Again, good luck, Daniel.
So, hi everyone, my name is Daniel Kmak. Today's presentation is going to be about building on UTXO blockchains. So, I'm Ethereum developer mainly myself. I believe I'm in the space since 2017 and I spend most of my time programming in Ethereum and integrating Web3 applications. I'm probably more front-end developer, but now I'm working in developer relations at Nervos Network, which is UTXO blockchain. So the goal of today's presentation is really for all you Ethereum developers out there, as we are heading into this multi-chain future, or maybe we're already there because there's so many chains that that we're able to build their technology. So the point is, if you are Ethereum developer and you want to integrate with some UTXO chain, so maybe today's presentation is going to be at least a little helpful to you in terms of some issues that you can face and maybe how you can solve them and where we are today. So this is agenda for today. We'll start from existing UTXO blockchains, and then I'll talk a little bit about what is UTXO and a little bit about how it looks to program on Cardano and Nervos. So I'm working at Nervos for last 9 months, and this is the time that I spent learning how UTXO programming works. I didn't do much programming on Cardano, although I tried to give you just like a glimpse how it looks right now. So we have a couple of UTXO blockchains. So obviously Bitcoin is UTXO blockchain. I don't think there's much programming you can do on Bitcoin right now, but I think there's going to be Taproot upgrade, where there will be more scripting possibilities on Bitcoin. So this could be interesting how it works out. And so obviously copies of Bitcoin, but as well, recently UTXO Alliance was formed, and basically the role of this UTXO Alliance is to face UTXO programming problems and overcome them for common good. So I think the most popular UTXO blockchain after Bitcoin is obviously Cardano. Recently, they introduced smart contracts with, I think, the Alonso upgrade, and we'll talk about it a little bit. And at Nervos, we have smart contracts, UTXO smart contracts for a year or two, I believe. And there's also Ergo and Top, and they are also part of UTXO Alliance. So when you are programming on Ethereum right now, you might not be familiar with what is UTXO. So basically, it's a different way of formatting your transactions. So you have inputs and outputs. You need to consume. Some, like on Ethereum, you have this concept more like a bank account, where you have one bank account and your balance is on this one bank account. But in UTXO model, you can think more like you have multiple safes with your money, and basically each time you want to do something with this money, you have to take all these multiple safes, form them into one transaction, and each time you do this transaction, you actually move all this safes somewhere else. So you can't target their location again, because if you took something for your transaction, like as an input, then you consume this input and it results in a new output. And this new output, when it's still not spent, not used in another transaction, let's call it second transaction, then this is what's called unspent transaction output. So this is really how Bitcoin works. So to really understand how UTXO programming is different from programming on Ethereum, you have to understand this difference that I specified before. So on Ethereum, you have the account model, where you can think of this metaphor where you have like a single bank account and you have your balance there and all your money is there. And if you are sending smart contract transaction, then you target this specific account number, and you can move your funds, and it's probably more straightforward to you. So yeah, regarding other things, you have a global shared state in your smart contracts. So when you are sending transaction, your smart contract can basically call any other contract and access any other global state. So this is also going to be different in UTXO programming model. And just for the sake of structuring this a little bit, the model that Ethereum is using is called the account model. And yeah, you can have multiple competing transactions which change the same state in a block, and basically the most important part is their order. But you can have one transaction that, for example, let's say you have a counter smart contract and you have one stored in the smart contract. You can have two transactions in the same block, where the first transaction adds 1 to this number and the second transaction adds 1 to this number, and the result will be 3, and all will be fine. And yeah, they can happen after each other, and they are using the same smart contract address. This really is not that straightforward in UTXO programming model. So Cardano and Nervos and these other blockchains are using UTXO programming model. So, and both Cardano and Nervos use advanced programming model for this, which means, so for example, on Nervos, you have RISC-V virtual machine, and you can do really a lot of stuff. You can import Rust libraries, etc. So it's like capable of a lot of things. And yeah, in UTXO programming model, you have to take these multiple smaller sums of money stored in multiple places, combine them together to produce an output. But each time you take these safes, you take these smaller sums of money, their location is changed. So to give you an analogy, in Ethereum, it's like in Ethereum you would have a smart contract, but after the first transaction, let's maybe go back to this counter example. After the first transaction that adds 1 to our stored number, the address of the smart contract is changed. So the second transaction that was sent in the same block will actually be rejected. So yeah, this is called like shared state problem in UTXO blockchains, and you have to work around this problem in some way if you want to program on UTXO blockchains. Yeah, your total balance on UTXO blockchain is the sum of all these smaller safes stored in like multiple places. Each time you use this safe for a transaction, it's destroyed and you have to create another one with a different address. So if you compare UTXO to the account model, these are the main differences, I would say. So first kind of benefit of UTXO blockchains is it's probably easier to do parallelization by design, because you have to declare all the locations that you are going to change. Because in UTXO blockchain, you have to specify all the inputs. So the program knows that these inputs will be destroyed and cannot be used another time. But really on Ethereum, it's a different programming model. So it might be harder to parallelize this work, because each smart contract can change state of all the other smart contracts. So yeah, there's no shared global state. State generation is moved off chain. So in Ethereum, if you send transaction to a smart contract, then it's possible that your smart contract is doing state generation as well. So basically, state generation is if you have your smart contract, and it will happen in a function body of your smart contracts method, because it can, for example, change some string, or maybe add some words to another word, and this is called state generation. In UTXO blockchains, on chain you are doing only state validation, and you are doing this state generation off chain. So theoretically, it should the logic on chain should be lighter, but in practical examples, you also have to sometimes compute the correct state and then compare it to the state that was passed. But it's more like validation logic on chain. And yeah, you have to not only gather your inputs for your transaction, but you also need to like calculate all the outputs. So this actually, so I don't want to say that UTXO model is better or account model is better, because I think they are just different. And for me personally, it's too early to decide which one is better. Definitely, I think account programming model like on Ethereum is easier for me to understand and wrap my head around it. But one of the benefits of UTXO programming model is that because you are computing all the inputs and all the outputs, and you pass this to a block producer, you don't pay for failed transactions, because your failed transaction will be immediately rejected after it's validated. So I think this is something cool. So programming on Cardano has been a huge talking point over the last couple of months, because there was also a lot of food around, like, programming on UTXO blockchains, and the crypto Twitter was tweeting a lot about this topic. But I think it's maybe more related that we as humans fear the unknown. So we are so used to what we have seen so far, to Solidity smart contracts, the account programming model, that if we see something different, if we see new problems, we don't have a good way to work around these problems yet. So that's why maybe we are kind of worried about it, because this is something we don't know yet. I think there's still a lot of research going on in terms of like UTXO programming. Cardano has their model where they are using, for example, Haskell. They have their own language called Plutus, and also other more like domain language called Marlowe. I think Plutus is more popular, and it's using Haskell environment. So I don't have much experience with Haskell, so it was very hard for me to write something, even though I have used some UTXO programming experience in a different UTXO blockchain. But still, it's interesting, and we will take a look in a second in example, you can say, smart contract on Cardano. But yeah, state generation is moved off-chain, state validation is on-chain. Cardano also has endpoints in their smart contracts, which you can treat as methods. So in Ethereum, you can call, I don't know, counter.increment. And in Cardano, you also have these endpoints, which look just like some methods. And you can also pass arguments from what I've seen. And Plutus contracts, I think they consist both of the part that runs on-chain and off-chain in the same contract. But I'm not really sure how this works, so I'm not going to talk about it too much if I don't know something. So yeah, this is example Cardano smart contract, you can call it like this. And yeah, interesting parts, you have these endpoints declared, in this case publish and redeem. So I think the goal of this smart contract is really that one person is creating this smart contract and specifying some secret number and depositing some funds, and the second person can call redeem and get these funds if they pass the correct integer. So this is really almost full smart contract that should be doing it. As I said, I'm not a Haskell expert. I didn't do much Cardano programming, but you can clearly see it's different than what Ethereum has. And these examples are from Plutus Playground, from Cardano, where you have some examples. Let me show. Yeah, so this is Cardano Playground for writing their smart contracts. We can click simulate, and then it simulates like you have two actors, wallet 1 and wallet 2. You can specify some actions on the blockchain. Like the wallet 1 is calling publish, wallet 2 is calling redeem, and theoretically wallet 2 should redeem the funds that wallet 1 published. So we can call evaluate and see how it goes. And I'm doing this also because they have these nice graphs where you can visualize how transactions look like on a UTXO blockchain. So this is transaction 0 in slot 0. So slot 0, you can think of it as like block 0. Loveless is, I think it's the lowest denomination of ADA, which is currency, native currency of Cardano. And as you can see, so the first transaction is really just like Genesis transaction. So it's giving some funds to wallet 1 and wallet 2. And you also have these statuses of these UTXOs, because this is UTXO and this also is UTXO. You can probably differentiate between two types of UTXOs. One would be account UTXO, so just like some user holding some balance, and the second type would be a smart contract UTXO, where it's a smart contract. So the same thing as on Ethereum, or at least you can think of it that way. So yeah, if we look at wallet 1, we can see this was spent in slot 1, transaction 0, which means if you try to target the same UTXO after slot 1, you won't be able to because it was spent. So you have to take this in consideration when you are building your transactions, because you either have to off-chain aggregate your transactions and then submit everything as a one transaction and only change this UTXO once, or you have to wait until someone else has already like consumed this UTXO and created another one, and this is when you can jump in. So it's also important that you have indexer tools that are effectively indexing your blockchain, and you can quickly query this data and build your application based on that. So I don't want to make this presentation too long because there's already a lot of information, and I just wanted to be like a little teaser, but I guess there's a lot of info. So let's look at block number 2, and you can see we took wallet 1 and we created new UTXOs. One of them is a script. So I think we should have 4 slots here or 5 slots, but I think there's some problem here because when I look at the logs, I can see CE key evaluation failure. So I guess this is one of the problems you might face when you are working with UTXO blockchains, when you try to do some UTXO programming, is that the tools still are relatively new. So I'm not sure why I get this error, but this is where Cardano is recommending people to go when they want to start programming. So I guess probably maybe there's some better resource hidden somewhere. I usually recommend people to just go to Discord and talk to people who actually develop contracts to get some help from them. So let's get back to the presentation. On Nervos, instead of Haskell, we are using Rust, but these contracts will also look very different from what you are accustomed to in Solidity. But also state generation is off-chain, state validation is on-chain. We are using Rust language with no STD directive, which means you can use some of the Rust libraries. But yeah, I don't want this talk to be Nervos specific, more like UTXO things in general. But yeah, for example, we are using JavaScript for off-chain code. So this would be a difference to Cardano, where I think they are using also Plutus Haskell language for the off-chain part. I guess not everything, but yeah. So yeah, this is why our blockchain is called Nervos, because our UTXOs are called cells, and in a human nervous system you also have axons which kind of look similar to UTXOs. And these are example Nervos contracts. So yeah, you operate on transaction input and the outputs in Rust, and you are doing validation. So this is really simple validation. So here we are doing, I think this is just like a simple token on a Nervos network. So you are just calculating whether the sum of a token in the outputs is lower or equal the tokens in the input, and you are selecting UTXOs which are of a certain type, which in this case would be a token and a specific token. Because it wouldn't make sense if you would just count any token. So as I said, the biggest problem in UTXO applications right now, I think, is this problem where after you change state, you can't really do it again using the same address because this UTXO was destroyed. So you probably have to aggregate these transactions off-chain. And this is causing some different problems. So also in this model, it could be easy to do denial of service, because you can imagine someone just sending transactions one after another and all the time consuming this UTXO, changing address, and then another person has to wait until they are finished. So this is what it looks right now. But you can work around this in some fancy ways, some better than the others. So for example, you can create multiple UTXOs. For example, these are diagrams of creating decentralized autonomous organization. So you can have multiple UTXOs, which itself maybe do some calculation just on a part of the state. So when user is sending transaction, they can maybe choose which UTXO they are sending to, and at the end you consume them by some collectors, and then you aggregate everything on chain when you are ending, for example, the vote in this case. So this is example how you can create token sale contract, but yeah, I think it's too specific, and probably maybe there's already too much knowledge to really understand for the first time. If it's the first time, if you hear about UTXO programming as Ethereum developer. But yeah, basically all these things written here is just like trying to get around this problem with the state. Some example JavaScript code for working with Nervos. It's basically just like constructing transactions, so nothing really super interesting here. And yeah, some tips for building UTXO applications, at least from what we've seen at Nervos. So you probably need a good indexer working with your blockchain client, because you have to query UTXOs by different things. For example, you need to get tokens of a certain type. And yeah, maybe one thing more here. Your UTXOs so at Nervos, for example, we often target these UTXOs by who's owning them. So we index them by the public key controlling them, but it's in a slightly, I mean, it's very similar to how you would do, I guess. Or no, it's different than in Ethereum, but you basically, one of the main ways is to just, try to find all UTXOs logged by Ethereum, logged by, for example, because you can use Ethereum keys also on different blockchains. So you could choose all the UTXOs logged by this Ethereum public key, and basically it would give you all these cells that are locked. So UTXO blockchains also figured out that, it's hard for Ethereum programmers to understand all of this, what I just talked about. So for example, at Nervos, we already have EVM layer 2 optimistic rollup, where you can just use, Solidity to build stuff, and really you just need to, if you don't want to do layer 1 programming using some UTXO programming language and, solving these problems, you don't have to. But in some cases, if you would like to build more advanced applications, you probably need to do some programming on layer 1, maybe if you want to change. If you want to add another public private key cryptography, some things like this, you probably would have to do some UTXO programming. But yeah, Haskell and Rust blockchain developers are pretty expensive. There's not much code you can reuse already. If you are building on Ethereum, there's great community, a lot of tools you can really reuse, and maybe many projects started as a forks of a different projects. It's easy to find help on different discords. So yeah, as I said, Nervos already has like EVM compatible solution. From what I have read, Cardano also was working on something called KEVM and some other Ethereum sidechain. So probably if you would like to do something, you can probably also use Solidity on Cardano. Maybe not now, maybe in some time. But yeah, this is how these UTXO blockchains are trying to also make it easier for people to just program on their blockchains. So this is example application deployed on Nervos layer 2. This is Ethereum application, by the way. So yeah, it's written in Solidity. And yeah, it's much easier to use our layer 2 right now than it is to use our layer 1. So yeah, that's been actually everything. And I know there was a lot of information, but just try to maybe remember just a few things, just the main differences between the account programming model and the UTXO programming model, and just remember that there exists a different programming models than what you have in Ethereum, and maybe in the future where you have to cooperate between all these different chains, you should be aware of that there are blockchains with a different architecture, basically.
Daniel, thank you for that presentation. If the audience has any questions, guys, this is the moment to ask them. Yeah, Daniel, so I wanted to chat with you about the local blockchain community here in Poland and in Warsaw. We've been brainstorming some ideas for doing a local meetup here in Warsaw. What do you think about the blockchain scene here in Warsaw?
I think it's very good. So the blockchain community in Warsaw, it's why I actually moved to Warsaw, because at that time I think I was at DevCon Prague, and I have met some people from Warsaw, and they were all engaged in some interesting, ambitious projects, not like good projects in Poland, but just like good globally. So it was really refreshing to see that we have such people here in this country. And yeah, the Warsaw community is very welcoming and very technically capable, I would say. So and professional in terms of like organizing events. So yeah, I think if you are from abroad and considering going here to maybe give some talk, then it definitely makes sense, because you have a good chance of meeting people that are on your technical or professional level.
Yeah, I agree with you that we have many highly skilled engineers here in Warsaw, and I think that there is room for an event that would show the technical capabilities of the community members that we have here in Warsaw. So far, my experience has been that the crypto events are more aimed at crypto newbies. So I think it would be really cool to do an event for more skilled people to do a deep technical dive into the aspects of blockchain and cryptocurrencies.
Yeah, you have these different types of events, right? So you have events of like Bitcoin Miami type, where and you also have deeply advanced technical meetups. And probably if you're a developer, you want to go to this technical meetup because you are operating on a different level of knowledge. But yeah, I guess these people for like crypto newbies are also important, but yeah, just different in their character.
Yeah. So let's work on creating a cool event for the Polish community here in Warsaw. We have support from the Ethereum Foundation for doing an offline meetup. We are part of Road to DevCon now, so that should give us a nice boost. And I'm going to Lisbon next week, so hopefully I'll find someone interesting to be a guest at our event. The preliminary date for this event is November 14th, but we'll give more announcements soon once we have more details to share.
Cool.
Yeah. Daniel, thank you very much for joining us today. Thank you for your time and the great presentation. And I hope to see you soon at the event.
Thank you, and good luck to you guys, and good luck for all the future 0xHack meetups.
Thank you, Daniel, and thank you everyone for joining us today. The meetup will be recorded and posted on YouTube, and the next meetup is, as always, on the second Tuesday of the month. So join us next month. See you guys.